Hello everyone. Today I'll be participating in this Leetcode Biweekly contest, and it's about to begin. Mm, Sorry for the background sound. Uh, okay. Rate limited. No, 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 no. The shit. Find consecutive integers from a data stream. Okay. For a stream of integers, implement a data structure that checks if the last k integers passed. Okay. Categorize box according to criteria. Four integers, length, width, height, and mass, representing the dimensions and mass of a box, respectively. Return a string representing the category of the box. If the box is bulky, then any of the dimensions of the box is greater than or equals to 10 to the power 4, or the volume of the box is greater or equal to 10 to the power 9. If the mass of the box is greater or equals to 100, that is heavy. If it is both bulky and heavy, then the category is both, nor, then neither. If it is only bulky and not heavy, okay, okay, okay. If any of the dimensions of the box is greater than or equals to 10 to the power 4, or the volume of the box is greater or equals to 10 to the power 9. So these three describe the dimensions, right? Or the volume. And how do we calculate the volume? Volume is this thing. Volume equals density equals mass by volume, or volume is just simply equals to length into width into height. Yeah, I think so. So how to check if it is heavy? Okay, so mole is heavy, mass greater or equals 100, mole is bulky, right, equals length greater equals 10 to the power 4, or width greater equals 10 to the power 4, or height greater equals 10 to the power 4, or probably, yeah, there was an easier trick I think that I just missed, but it's fine. Now let's say long and volume equals 1 initially. Now volume multiply equals to length, width, height is bulky or equals volume greater equals 1e9, I think. Yeah. So now if is heavy and is bulky, then return both. If it is heavy, if it is bulky, otherwise return quickly. Yeah, N and B both should be capital. compilation error, spelling mistake, typo, heavy and neither. Let's see. Cool. And then data stream class int value int k initializes the object with an empty integer stream and the two integers value and k. Okay, where value defines checks if the last k integers parsed in the stream are equal to value. Okay, now boolean concept int num adds num to the stream of integers, true, false. Okay, so we can have a counter, I think. Let's call it counter, which is initialized to 0, and int, let's call it v equals value, let's just call it kk. It is initialized here. Now if num equals v, then do counter plus plus and return counter greater equals kk, and here in the else part reset the counter to 0. So they have not mentioned anything like sorting. Null and 4 false. No, 1 true. Yeah, this should be fine, I think. Pending, judging accepted. Finds Xor-Beauty of array 0 index integer array. The effective value of 3 indices I, j and k is defined as nums I or nums j and nums k. Okay, the Xor-Beauty of the array is the XORing of the effective values of all the possible triplets of indices. Return the Xor-Beauty of nums. Okay, all possible triplets. What are the constraints? 10 to the power 5. We'll be doing nums k. So this AND part is quite important. Also, can we somehow simplify this formula in terms of XOR? Like a bit will be 1 if it is 1 in odd number of numbers, something like that. The triplets and their corresponding effective values are listed below. Oh, so I, j, k both can be equal as well. Like all three can be equal as well. Effective value, this. It is a medium level problem. 17 people have already got that one. Mm. Bitwise or and and in the end we are just XORing all the effective values. Hmm. So if some bit is set here, hmm, in the end we can see that we have 2 times 4, 3 times 4, 3 times 1 and 2 times 0. Hmm. In this case, so this is kind of like just XOR of 1 and 4. Hmm. So if it is like all the numbers are equal, then the answer would be just the XOR of all values, right? Hmm. 110. Uh, Maybe I will have to use pen paper in this problem. Hmm. Oh, so there can be one catch where that is this value will be calculated twice, right? Here and here. So they will just cancel out each other. Yeah. So this is when the k value is constant, but I and j are, yeah, the I value and the j value are just shuffled. So in total, I will be having n into n into n. n cube triplets, and out of which every such pair hmm, every such pair will cancel out each other where I and j both are not equal. And if I and j are equal, then like in this case, and what I am doing is that 1 and 1. So is there some formula for like XOR of two AND values? XOR formulas wiki. I remember I've seen some formulas of XOR formulas in terms of bitwise and wait a minute. The odd value is same. Then I'm doing AND. So 1 and 1 will give me 1. 1 and 4 will give me 0. And after that I will have to XOR both these values. So what I was thinking is that uh, let's say we know that a particular bit will be set, so like ones is m times and zeros n times, then can I somehow calculate will it be set after the XOR of all m and n values? So these all n times will somehow give a 0 only, and these, so if m is an odd number then it will be 1, otherwise it will be 0. I think, will it be true in all cases? Yeah, I think it will be true in all cases. Okay, CNT while num if num and 1, then do count of I plus plus Okay, so this way I am keeping the count. Like in the count map, I'll be having that which bit is set and how many numbers, right? So later on, I think I can use this thing. Hmm. So nums I and all the numbers. Now if C and T of I and 1, so if it is an odd number, then do answer XOR equals 1 left shift I, something like this. Otherwise don't do anything. I plus plus nums I right shift. Oh, num and nums. Then just return answer. I think this should work. Not nums right shift. Num right shift. Come on. I'm afraid if I lose all the. Oh, come on. Five and 34. Yeah, I think this should work. Yep. Maximize the minimum powered city. How many people have got this one? 16. Okay. You are given a zero index integer array stations of length n. The station side represents the number of power stations in the ith city. Each power station can provide power to every city in a fixed range. In other words, if the range is denoted by R, then a power station at city I can provide power to all cities J such that I minus J, the absolute value of I minus J, is less than or equals to R. So it is kind of a radius thing. If the range is denoted by R. Yeah. The power of a city is the total number of power stations it is being provided power from. The government has sanctioned building K more power stations, each of which can be built in any city and have the same range as the pre-existing ones. Given the two integers R and K. Return the maximum possible minimum power of a city. The additional power stations are built optimally. R is 1 and K is 2. What is K now? Oh, K is the number of stations that are going to get built. K more power stations. Of the optimal ways is to install both the power stations at city 1. City 1 is just one. So stations will become 14450. At what? City 0 is provided by 1 plus 4 equal 5 power stations. Okay. Yeah. So this value, if I'm installing both the power stations there, then it shouldn't it be 6? It is 9, it is 13, 9 and 5. Mm, oh, R is 0. Yeah. Redundant maximum. Uh, I mean, I see their point that even if you install, even if it is like 6, the power will be 5 only, but one of the optimal ways is to install both the power stations at city 1. So, oh, so stations I represents the number of power stations. I thought it is the power of city I at first. Okay, okay, okay. This is 2 plus 2. Oh, okay. And they are not circular in nature, right? Yeah. Mm, I think we should use some kind of a priority queue. Uh, but the value of k can be 10 to the power 9. This can be a problem. So in the priority queue, on the top of it, I'll be having the power station with the minimum number of power stations currently supplying power to it. Now I know that I have to increase the power of this power station. For that, I'll have to increase the number of power stations in some of the other cities, but exactly in which city? That will be the question. Hmm. For that, can we assign priority to stations as well? Priority to cities as well. Like increasing the number of power stations in city I will increase the number of power stations in these many cities. But that can be problematic because sometimes this priority can be same for many cities. Hmm. Like in this case, these three cities will have the same priority, 2, 4, and 5. 2 is supplying power to this one and this one. Similarly, 4 is supplying power to 2 and 5, and 4 is supplying power to 2 and 5, and 5 is supplying power to 4 and 0. And 0 is supplying power only to 5. Hmm. Hmm. But wouldn't it be optimal to increase those power stations at the rightmost or the leftmost power stations? Yeah, it would be, but then the question arises, in the leftmost or in the rightmost? I mean, if we are going like this, then obviously the rightmost. Yeah. And after that, I think we can use binary search for the maximum possible minimum power thing. Hmm. But I think it will again become n times log n square time complexity case, which can be problematic. Hmm. Hmm. Or should I just get the code of fan victory somehow? But isn't there some simpler way to do it without using fan victory? Yeah, I think it can be done in n log n time as well. Low, let's say 0, high, I don't know, while low less than equals high, mid equals or low plus high minus low by 2. Check. Let's call it as only RK and mid. Then low answer equals mid. Low equals mid plus 1. Else high equals mid minus 1. Return answer. Boolean checker function. Srk and I don't know p. Hmm. Prefix sums will be required. Cur, cur represents current power, which would be s of I plus k, s of I plus r, mhm, minus s of I minus r, minimum of 0 comma this, and maximum, no, minimum of n comma this, and maximum of this and this. Now if cur is less than p, or instead I should call it target, then long diff is tar minus current, let's have a queue of pair of long to int and running some variable uh, this thing plus run. While queue is not empty, and queue dot front dot second is less than I minus r. Yeah, run minus equals to queue dot front dot first and queue dot pop. Now if difference is less than k, then just return false, otherwise return true. And here do run plus equals to diff as well as push it into the queue. Diff to I, not I plus r. Yep. Oh, yeah, one thing I was missing was that k minus equals to diff. So this R won't be changing. Okay. Actually 1E14 will work as well. Hmm. Yeah, that is fine. Hmm. Hmm. But why though? This S of I minus plus 1. Yeah, but still, Q is not empty and Q dot front dot second is less than I minus R. This cannot be wrong, right? Okay, so this should happen for quite a lot of times. No. Is it like I cannot compare an integer with a long number? That should not be true. If difference is greater than k. Final answer 5 and 4. Yeah. Let's submit it. Cool. What's the final rank? I got all correct in the first go itself. No got na. People were able to do it in 31 minutes. It is not yet updated. 14 minutes. Yeah, somewhere around here. Most probably. Okay, so now it's time for the explanations. So this problem is pretty straightforward. We are given length, width, and height and the mass of a box, and we have to return a string representing the category of the box. So if any of the dimensions like length, width, or height is greater or equals 10 to the power 4, then it will be called bulky. Or if the volume of the box is greater than or equals to 10 to the power 9, then volume means just length into width into height, then also it is called bulky. So for checking bulkiness, here I am calculating the volume, and as bulky is the boolean variable which will hold true if the box is bulky, otherwise false. So yeah, here it is just I'm checking for this first case if any of the dimensions is greater or equals to 10 to the power 4. Later on I realized that I should have done something like that. It would have saved me a bit of time at least. And then yeah, here I am calculating the volume, and yeah, for heaviness just mass, if the mass is greater than or equals to 100, then it is called heavy. And at the end I'm according to the values of both the boolean variables returning the answer. So this was a simple problem. And yeah, one important thing there to note is that if you try to calculate the volume like this, length into width into height, then I think this will throw a runtime exception because the integer limit will overflow. But doing something like this is absolutely legit because it is nothing but equals to this volume into this. And here, since one variable is of type long, the other one will automatically be converted, or the stored will automatically be converted into a long thing. But in this case, this is an integer and this is also an integer. So in some cases, yeah, in case of length being 10 to the power 5 and width also being 10 to the power 5, the limit will overflow and you can get a runtime exception. So I first initialized the volume variable to 1, then I am multiplying 1 by 1. There can be some other ways also to calculate the volume, but I think that this was a pretty straightforward one. Going to the next problem, find consecutive integers from a data stream. I think this should have been the first problem because it was pretty simple. So let's first see what the problem wants us to do. We have to implement this data stream class in which we have to like first implement or like add code to the initializer, or what it is called, constructor, yeah, constructor. And then we have to implement this function also, consec, which is kind of a query function. So this initializer or the constructor will initialize the object of data stream class with an empty integer stream and the two integers value and k. So there is an integer called value and one integer called k. And the consec function will return true if the last k integers that are inserted into the stream are all equals to k, and false otherwise. And yeah, if there are less than k integers, then the condition does not hold true. So last k means at least last k integers. So yeah, here I am just storing the values, both these values, value and k, into v variable and kk variable. This. And then when I am inserting a number, it is kind of a 1D DP thing, and yeah, it's just the simpler version of it. So instead of storing the vector and putting like vi plus equals vi minus 1, like keeping the prefix sum in that vector, I'm just having a single counter variable because the previous values are not really required. Only the last value is required, but the last second and the last third values are not really required. They can be accumulated in the last value itself. So if the last number that was inserted, or the number that we are inserting into the data stream, is equals to v, then I am just incrementing this counter. Otherwise I am resetting counter to 0, because since one number or one element that I am inserting into the data stream is not equals to value, like in this case all the numbers should be equals to 4, but now when we are inserting this 3, the counter should reset to 0, because now all the numbers that will be inserted, like if we wait a minute, let me have it like this. And now if we are inserting 4, then in no world we are going to return true for the next inserted number as well. Like even if we insert another 4 here, still the count would only be 2. It would not be 4, because in the last 4 numbers there is one number which is not equals to value. So here itself it should reduce to 0, and now it should be incremented to 1, and here it should be incremented to 2. So counter is just storing the number of last inserted numbers that are equals to value. So for example, in this case, here the counter will become 1 because the last inserted number is equal to value. Here it will become 2. Both the last inserted values equals to value. Now all the last 3 values inserted are equals to value, and here it will become 0 because the last inserted number is not equals to value, and doesn't matter whether the last 3 or any number of numbers are equals to value or not. Now at least for the next k cases or k minus 1 cases, I cannot return true. And here it will become 1, here it will become 2, and if we like insert one more number, then it will become 3, and here I will return true. This was also a very simple problem, I think, and it could have been the first problem as well, but I think that since it requires some bit of this class implementation thing, they decided it to keep it as the second problem. Find Xor-Beauty of the array. It has these many accepted submissions, but I don't think it is that of a simple problem. Think I think it is not that simple because first of all you have to observe this thing that okay, so firstly what the problem states, just quickly look at that. The effective value of three indices, we are given a zero index and these are enums, and we are given some definition of effective value of three indices. So the effective value of three indices I, j and k is defined as nums I or nums j and the AND of nums k with the resultant of that OR operation. Now the Xor-Beauty of the array is the XORing of the effective values of all the possible triplets of indices I, j and k where I, j, k are in between 0 to n minus 1. Now return the Xor-Beauty of the nums. So here they have explained they have basically calculated all the possible effective values and then just XORing it and returning the answer. So one thing that you need to keep in mind, or it is just a property of XOR, which is that XOR cancels out same values. So if we are doing something like 1 XOR 1, that will give 0, or 2 or 2 it will give 0, or in more general term if you are doing m XOR n, it will give 0 if m equals n, right? So when we are going to calculate the required value, or we are going to calculate the value of the expression, which is something like I don't know how to insert that summation symbol mm, summation or XOR symbol rather I, j, k, we are doing XOR something like, oh, let's not do that. So how I am going to use this property is that whenever we are doing I XOR j and k, so its value will be 0 because if I is not equals to j, because there can be two cases, one when we are doing this, and actually it is not quite true that it will be 0. So if it is this, then because there will be two cases, firstly I am doing this and then later on I will be doing this as well, j or I and k. So the OR value will not get affected at all, so, and we are doing the AND of k with the exact same odd values, so both of these values will be same, right? So because this will be equals to this, I or j and k will have no effect on our answer, right? This way we can neglect both of these values. Similarly we can neglect this thing as well. So now the only values that are left are I or I and k, and we will be XORing it with the other values I or I and k, and so on. Like the value of I will be from this to this. Similarly, the value of k would also be from this to this. Now it is just a very straightforward question because we essentially just have to calculate the value of this expression for all possible doublets or all possible pairs of indices, and then just do the XOR of them. Now XOR also have this property that if the ith bit is set, set means equals 1 for odd number of times, the result will be 1, otherwise it will be 0. So this is the property of XOR, right? So this way, firstly I am counting out that how many times a bit is set. So let's say there are, in this case there are two numbers and one can be represented as 1 equals 0 0 1, and 4 can be represented as 1 0 0. So this count map will store 0th bit is set one time and the second bit is also set one time, right? It will not store like 1 to 0, but that is understood because in map if a value for a particular key is not inserted then it is default to 0. Something like 1 to 0 is understood. So yeah, this way I'm just creating this count map. Then later on, this property that I have explained it here is used here because so this num can be considered as this k thing, k, because it will be, I'm doing the AND of this number. So this checks that the 0th bit or the ith bit is set in the num. And then I'm counting out that in how many numbers this bit is set. It is set in num, so that's why in the resulting XOR also this value will be present, this bit will be present. Now I am just doing the XOR of all those set values, so that resultant XOR would be 1 if the number of times it is set is odd, as I have written it here. If it is odd number of times, then the result would be 1, else 0. Yeah, so this way, if it is like not set, or if it is for even number of times, then the answer will not be affected by it. Similarly, here also, if that bit is not set in the num itself, then it doesn't matter in how many numbers it is set because this AND expression will give only 0, right? Then at the end I'm returning the answer. So this was, according to me, not a simple problem, but apparently 5,000 people have solved it. 5,750 people. Okay. Now moving on to the fourth problem, maximize the minimum powered city. This was a nice problem and a hard one as well. The hard part is just implementation, and also yeah, the logic thing is also not easy. So I am using binary search on answer to get the answer. Here I've calculated this prefix some kind of array where yeah, just storing the number of power stations, the prefix sum array, and then yeah, these two variables that are used for binary search, low less than equals high, and this is where I am calling the checker function. So this target is basically representing a candidate answer, which is this maximum possible minimum power of a city. I'm not going into the problem because I think you have already at least read it once and you understood what the problem says. So yeah, I am doing binary search on answer, and one observation that I have used is that let's say let's say this is the problem. These are the stations. Then in order to maximize the answer, or in order to add the power stations to a particular city, now how to select like in which city how many stations we should add. So for that I am assuming, or I am I just figured it out in the contest that I should always add power stations to the rightmost city that is affecting the current city, or affecting the number of power stations for the current city. Like in this case, R is 1. So for city 0, it would be like city 0 and city 1. And this power is 3. Number of power stations is 3. Now if we want to maximize this number, then I should always increase the number of power stations in the rightmost city. So like in this case, I should always increment the number of power stations in the city 1. Here case 2. So the power of this city has been incremented by 2 to 4. Now when I'm doing binary search, then the target value also can be 3 as well, and it can be 4 as well, it can be 5 as well. So let's say when it is 3, when it is 4, or let's start with 3 only. Let's say when it is 3, then what I'll do is that I will not change this value because already this minimum power is equals to 3. So there is no need to change it. No need to add more power stations to it. But when the target value is 4, and I'll say that okay, 3 is less than 4, then why not add 4 minus 3 equals 1 stations in city 1. So this way city 1 will have 2 plus 1 equals 3 power stations. So why am I adding it in the rightmost city only? The simple reason of it is just that, let's say in this case when I am here, or when I'm let's say here, then for city 2 it would be city 0, plus city 1 plus city 2 and uh, plus city 1 for city 2 it would be city 3 2 and 1. So had I added one station to this one, and city 0 would have had two stations, then till city 1 it is absolutely fine because its number of power stations will also get incremented by 1. But here it won't get incremented by 1, right? Because here I am not taking city 0 and I am taking only city 1. So yes, it's like I am giving priority, or I am assigning some kind of priority to rightmost city only, because that would be that would affect the most number of cities. Let's put it like that. So that that's why only the rightmost city is important. But I think if we go backwards, then the leftmost city would be a right choice as well. So yeah, I think there are multiple possible implementation things. So like here I am doing 1 2 n. You can also like reverse that and then do the same thing, but the answer won't be different. Implementation thing can be different. And so yeah, when I am adding a value or adding k to a particular city, adding that difference to a particular city, then it would affect that prefix sum array, right? So for that I was thinking of using a segment tree or a fenwick tree to get the range sums in log n time and also be able to modify a particular element in that tree. But I think the faster thing, because I think in Leetcode and log n square time complexity always gives me a TLE. So I thought of this solution where I am having a queue of pairs. Now this pair just simply tells us that in which city I have added how many power stations. So like in this case, when I am adding one power station to city 0, then the queue will store 1 and 0, where 1 equals power stations added and 0 is city number. So this way, before calculating this current power thing, like currently how many power stations are delivering or supplying power to the current city, I am first doing this where I am changing the value of this run variable. Run basically stores the running sum of all the currently added power stations. So when I am adding additional power stations, then I am also adding those power stations into this run variable and also inserting it into the queue as I have mentioned over here. Here. And here, when the front value or the like the city in which I have added the power stations first are out of the range of the current city, then I am decrementing or subtracting the power stations of that city, the additional power stations of that city from the running variable. So this way that log n time complexity, that additional log n factor, has been reduced to constant time. Well, kind of a constant time. Yeah, so this way I have solved this problem. Overall time complexity of this one would also be big O of n log n. Yeah, kind of log n. I mean, No, not log n. It would be log base 2 of 1e14. But yeah, kind of. I mean, it doesn't. It is still better than big of n log n square thing. So it would pass the time limits very easily. So yeah, this way I've solved this problem, and I think the overall rankings I should be in top 150. No, wait, what? Why not here? I am here, but why the rank is? I don't know, maybe some glitch. But okay, I managed to solve both problems in an hour, and that's good enough for me. Bye.